What up YouTube, TK here, and today I'd like to talk to you about my entry for the 2016 Hackaday Prize. I call this one the Ultimate RC Car. Please get ready to throw your hate in the comments and tell me why it's not the Ultimate RC Car. When I was young, remote control cars were one of my favorite things, but they were pretty limited. You could only drive so far away before the radio ran out of range. The batteries would only last, say 10 or 20 minutes. And you could only drive where you could see. If you drove around a corner, you had no idea where you were going. Now, I think I can fix all of these problems in a really awesome way. The plan for this beast of a machine is at once simple and complicated. I basically want to make a drone that I can remotely drive around over the internet pretty much anywhere in Australia, if not the world. Now, that might sound pretty boastful, but I think I've got it down.
So we basically start by tearing apart the existing radio control system, and we replace the brains of the car with a Raspberry Pi. To communicate with the car, we use a simple off-the-shelf 4G modem. This will allow the car to drive virtually anywhere, wherever there's a mobile signal. These days, mobile networks cover a huge swath of the Earth's surface, so this car shouldn't have problems going virtually anywhere. Now, the second problem is battery life. My plan is to hook the car up to a large bank of lithium batteries. I then want to combine this with a solar charging solution. Now, solar panels don't give us a whole lot of power per area, and the car is fairly small, only about 50 centimeters long by 30 centimeters wide. That doesn't give us a lot to work with. However, we can play the numbers by being smart about how we use the car. The car is intended to remain dormant during the day, charging its batteries, and then to be driven at night. Done correctly and with a bit of luck, we may be able to get the car to a point where it can drive and roam indefinitely, with some restrictions on its daily range. Building a vehicle capable of this sort of operation has always been a dream of mine. Now, the third problem is one of vision. You can't drive if you can't see where you're going, and this is where things start to tie together. You see, we've already got a Raspberry Pi on board for control, so all we have to do is hook up a Raspberry Pi camera or a webcam, stream that back over the 4G modem, and we're in business. Now, many available digital cameras are capable of seeing in the near-infrared range. This means we can outfit the vehicle with infrared headlights, combine those with the webcam, and we'll be able to drive at night without necessarily disturbing people passing by, or indeed, them even noticing the vehicle's presence. That's the moon. It's the moon. So the idea is, by outfitting this thing with control over the internet and a streaming camera and a load of batteries with solar power, we can basically create a vehicle that we can drive at night, recharge during the day, and just see how far from home I can get this thing. If I can get it on some kind of round trip of 5 to 10 kilometers an hour, over a series of a few days, that would be absolutely mind-blowing for me, and I'd love to see if I can pull it off.
So there's a lot to think about on this project. First of all, I need to tear the car down, look at the electronics, and see how I can use a Raspberry Pi to control the steering and drive. I need to find a way to camouflage the car so that when it's out in the wilderness charging during the daytime, people don't steal it or kick it around or generally pay it too much attention. And perhaps most of all, I need to focus on the software. I need to find a way to integrate a webcam with a Raspberry Pi, and then how to control that Raspberry Pi over the internet and get it to interface with the car and its systems. Now, I don't have a lot of experience in that area, but I think if I apply myself and look at what other people have achieved, I shouldn't have too many problems. The theme for the Hackaday Prize is to build something that matters. Now, on paper, building the Ultimate RC Car, it might seem like a bit of a toy. The thing is, if I can achieve the functionality I'm looking for, what we'll basically have is a land-based drone capable of operating wherever there is mobile network access. This would have all kinds of applications where you need a land-based vehicle with a video feed that you can operate from extremely remote distances. I'm basically keen to build this, A, because it'll be fun, and B, because I think it'll be a great demonstration of what you can achieve in 2016 with off-the-shelf technology. I'm really excited about this project, so I'm going to get stuck into tearing it down so I can figure out how to control this thing. Let's go. This gorgeous machine is a remote control car. My parents bought this for me when I was a young boy, got it for Christmas, and it's from Tandy, which is similar to Radio Shack in the United States, and it also no longer exists. So it has front suspension and rear, and it has four-wheel drive and working headlights, all very cool features. Just look at this thing. Big springs under there, big tough bumper because I did drive this into walls many a time. You know, just, it's an absolute monster. The antenna did used to stick straight up, not so much anymore. This thing does have differentials both front and rear. It is truly four-wheel drive. Original battery, oh dear, that's still in there. Original battery, which is still in there, is a 7.2 volt nickel metal hydride. That'll definitely have to go. We got our motor in here, quite quick for what it was. I quite enjoyed it, and yeah, pretty cool machine. One of the things I loved about this car when I was growing up was that it came with this tool that allowed you to take the wheels off. Now, there was no reason to do this. It didn't come with another set of wheels. The wheels don't really get damaged, but you could take them off anyway, and that was pretty fun. I'm not gonna lie, I did this like 5 or 6 times growing up just for the fun of it. Sitting up on its own tires, it looks exactly like the cars in that dodgy neighborhood your grandmother used to live in the 90s. Already this thing's starting to look completely different with the case off. We can see up here we have the typical steering adjustment that was common on all old remote control cars. We're probably going to lock that in place. We don't want that changing when we're out in the field. Steering mechanism doesn't look as tough as I'd like, but you know, what are you going to do? You can see there's also plenty of room for dirt to get in there. We've got our suspension, pretty cool. Yes, we have the original battery. Now, it did originally have a plastic case on it. I took that off. Now it looks more like a bomb than anything, but, you know, that's what happens. So the motor's here, the radio control brains will be in here. This is a cable that goes to the LED headlights. And then we've got our steering box in here. So we'll start by taking a look at the electronics. So here we have the connections to the motor and the battery. You can see the motor's just here. This wire is the antenna with a little knot in it for strain relief. So at first glance, things don't look too good in here, but this isn't actually corrosion. There's some poorly colored sort of plastic coating over these heavy duty traces. But that's not too much of a problem. We'll see if we can get this board out and flip it up. Underneath this nest of wires is actually what goes to the steering box. It's not really what I wanted to see because that's a little more complicated than I'd like, but hopefully it's not too hard. We have the main power switch that switches on the RC car. We have a hefty relay, 24 volts, 10 amps, pretty cool. Activated by a 5 volt control signal though, which is interesting, suggests the board uses 5 volt logic. Got an IC here. Now this doesn't show up on Google, there's no data sheets for it. I assume that's basically the thing that runs the whole show. We got a bunch of transistors in here. They probably do a number of things, probably run the radio signal and also probably help control the steering. And then here we have our main power transistor that would control the fat little motor that's under here. It's all probably pretty simple, but it's quite messy. It's a single-sided board as far as I can tell. And yeah, we've got basically 2 options at this stage. We can bring the Raspberry Pi in and try and wire it into this board so that it uses the onboard control for the motor and for the steering. Now that's potentially fairly easy. We know the components on here are spec'd to run everything. They shouldn't blow up. It should be simple. The other option is to get the Raspberry Pi and then completely scrap this. We then have to add on to the Raspberry Pi some sort of speed controller for this main motor, and we'd also have to find a way to control the steering, which we currently have no idea how it works. That could be tough. Just finding a speed controller to easily work with the Raspberry Pi, it's not easy. There are speed controllers out there that integrate well with the Raspberry Pi, but for the kind of current capability we're looking at and the fact that we need to do forward and reverse, we're looking at close to $100, and I really don't feel like waiting 2 weeks for them to ship. Again, and the steering box, there's probably no integrated solution to control that if they're doing something kooky here. So that could be a real headache. So what I think we're going to probably do is integrate the Raspberry Pi into the circuitry that's already on board here, figure out how to tell it left, right, forward, reverse, and go from there. Shouldn't be too hard, he says. I have a suspicion that forward and reverse is probably controlled by this relay here. And then, you know, just you got the power transistor to do on and off. But yeah, we'll see what happens. Let's dig a little deeper on that steering box, see what we can find out. The annoying thing is, to get to this steering box, I have to take all this suspension off. But we'll get there. In case some of you were wondering how this suspension works, it's actually really cool. So you can see it's rigidly mounted to the frame up here. We have our wheel mount down here. Now, there's 2 springs on either side, and if we slide this rail back after unscrewing it, it all comes free. And what you actually just have is these metal rods, 4 of them, that just go down into these fittings down here. So your suspension is sprung, but there is no real damping. But it's still a pretty cool little feature. And those are actually surprisingly, they don't feel that strong when they're taken apart. So yeah, interesting. It did feel like a pretty sturdy truck when I used to drive it around though. Oh, and look at this, there's a screw in there, and they've actually left the cutout for us to undo it. Now the optimist in me wants to say that that's because they want you to hack on this toy. The realist in me says that Radio Shack was getting this put together by underpaid laborers in China, and they were doing it by hand. Now this piece slides off the front. I've never seen anything quite like this construction before, but I do quite like it. It's rather elegant. And we're coming at this from a different angle now, as I think General Patton once said, if your first attack does not succeed, try coming at them from the bottom. That's what he said. This off. There is a spring that springs out. That goes in there to detent that against the grooves here. Now we will forget where that spring went when we go to put this back together. So if you look down in there, you can see the mechanism that does the steering, and there's a weedy little return spring. And you see this somehow shifts that back and forward. But it looks like the motor, or whatever it is that controls the steering, is still buried in here. We'll have to go deeper. So behind this cover plate is the motor that controls the steering. It actually looks like a fairly small sort of motor that's probably going to be geared down a fair way. If you are wondering why I'm so focused on the steering, it's because at the rear, all we basically have to worry about is a motor. One way or another, we can find a way to drive that. It's a simple brush DC motor. There's a few different ways we can go about it, but fundamentally, it's a solved problem. The steering, I have no idea how this works. It could be an absolute headache to figure out how to talk to this, how to get it working. At worst, we may have to rig up some kind of servo to replace whatever's already in here. There could be a mechanical headache as well as an electronic one. So that's why I really want to get in here and have a look at what's going on, because that could be the fundamental challenge. So we've finally got this unbolted. We can now wriggle that up like that. That's pretty cool. The drive shaft just... the drive shaft. Wow, this is interesting. So the drive shaft just comes out here, and it's just a flat little blade on the end there. And that just sits in that little slot. That's awesome. That's got nice positive engagement, but also doesn't have some big ugly screw through it and isn't difficult to detach. It just slides off. That's awesome. I wonder what this little secret compartment under here is. Okay, so it's a compartment for a 9-volt battery. I'm having a flashback to when I was 14 when I first took this apart. I think it confused me back then. Because this thing runs off a 7.2 volt nickel metal hydride battery. I don't know why it would need a 9-volt battery at all. I can only imagine this is for some, maybe this chassis was shared with other models that for some reason had a need for a 9-volt compartment. But yeah, that is truly strange. The other weird thing about this compartment is, to open it, you've got to take the whole truck apart. So I find that particularly confusing. Why would you put a 9-volt compartment in this thing that's also exceedingly hard to open? I can only think that maybe they use these to smuggle cocaine. If customs open it, they'd be like, nah, it's where we put our 9-volt battery, but actually they put cocaine in there, and that's why it was so hard to get to. They were just hoping that nobody would bother to look. Regardless, there was no cocaine in mine. The simple fact that this has 6 wires to it tells me that this steering mechanism is probably not going to be simple to control from an electronic point of view, which is sort of all the more reason why I'm hoping to probably use the onboard controller to control it, and I'm hoping there's somewhere where I can just send a 5-volt signal for left and a 5-volt signal for right or something similar, because I don't know if this is going to be easy to figure out. Just a friendly warning if you're ever doing stuff like this yourself. Complicated little mechanisms like this one are often full of gears and springs and little shims and other tiny little pieces that will jump around and fly all over the place as soon as you take it apart. I can guarantee the first 3 times you try and do something like this, you will drop at least 2 or 3 of these pieces, and one of them you will never find ever again, and that's it. That's your project over. Now, the way these suspension linkages work is actually, to me, quite fascinating. So this pin has about 5 or 6 millimeters of thread, and then it's just smoothbore, and what that does is it grabs on to this linkage, and then the rest of it just slides through there, and as long as it doesn't slip out of here, the part can, freely rotate up and down. That's really cool. I quite like the way of doing that. One thing to note is we don't want to screw and unscrew that too many times because that'll wear out the plastic thread. But we'll be careful. And we have it open, finally. Takes a bit of wriggling, but yep, we can see there's a gearbox in there, and that's covered in grease. You can see this is just a actually purely mechanical mechanism that just puts a bit of pressure one way or the other on the steering mechanism. So we might even just eliminate that entirely, just take that off the car. Okay, so we have here both steering box and differential, so let's not get confused. So we'll take that left half off. That's pretty cool. That part of the drive just connects to this part of the differential with a hexagonal fitting. So we can see here, power is input here, and that spins, but it's a differential. They can spin at different rates, so you can hold that and this side will still spin. Now it's just, as far as I know, it's just an open differential, but that's still giving you 4-wheel drive, which is very cool. So the steering box, which is really what we came here for, not the differential. If we wriggle that around, all we can see is that there's a board with 4 wires going to it and a motor with 2. Doesn't really tell me anything. We'll have to keep going. So basically there were a bunch of gears in here to up the torque from this high-speed small motor to enable it to turn the rather hefty wheels. That's simple enough. Now, why there's 6 wires? Well, actually, it didn't take me long to figure it out once I opened it. 2 wires run the motor. There'll be a controller on the main PCB that allows us to run this forwards or backwards. Easy enough. These other 4 wires. Now, these other 4 wires go to this board here. And you can see there's a series of contacts. So, don't exactly know how they work, but I'm guessing they act as a sort of encoder that basically sends the position of the steering back to the main board. Now, what I do remember from driving this around as a kid was when you turn left, the motor would turn the wheels left. And you hear the sound of the motor turning the wheels left. When you let go of the stick, it was clearly too hard for them to include some sort of spring to recenter the wheels or anything like that. So they actually had to drive the wheels back to center using the motor. And you hear again, as it drove the wheels back to center. That's not surprising. It is remarkably complex, though, that they actually had to use an encoder to determine the position of the steering and then send that back to the main board. Yeah. So I guess I got 2 options. I can either basically, number 1, try and integrate with the main board, figure out where it's getting its left and right signals from, send those from the Raspberry Pi and let it handle, driving the steering. Or I can try and interface this encoder and such with the Raspberry Pi, which I can guarantee you I'm not going to do. I just doesn't seem like my idea of fun. The third idea is to basically take this fitting for the steering, rip the rest out, and mount a big hefty servo in here. And that would be remarkably easy to drive from the Raspberry Pi. So that's my third idea. So I reckon we're either going to use the main board or we're going to just chuck a big servo in here. Quite the gear reduction there. I would imagine probably
I don't know, 100 to 1, 200 to 1. I don't actually know off the top of my head, and I don't quite fancy doing the calculation, but it's a big step down because the motor would be quite a high-speed little unit, and you do need quite a lot of torque at the end of this thing, so yeah. So basically now we've torn down the entire car. We've had to go a lot further than I expected, but we got there in the end. We know where the main drive motor is. We know how it sends power to the front and rear wheels. We now know how the steering works to a greater or lesser extent. Now the next real step is to start programming around on the main PCB, seeing where the control signals from the radio come in and how they activate the steering and the main drive. But yeah, I think we'll leave it there for tonight. Hope you've enjoyed watching this video of the Ultimate RC Car project, and yeah, TK out.